Okay. Now the next topic is transaction state in DBMS. Before going that, let's see what is transaction means. The transaction is a set of operations used to perform a logical set of work. A transaction usually means that the data in database has changed. One of the major uses of database management system is to protect the user's data from system failure. It is done by ensuring to make sure that all the data is restored to the consistent state when the computer is restarted after the crash. The transaction is one execution of the user program in the DBMS. Executing the same program multiple times will generate multiple transactions. So we are explaining here the transaction is nothing but a group of operations, or we can say it is an embedded system of operations to perform the logical set of work. So we have to protect it, restore it, and we have to do the execution in time with multiple times and with multiple transactions. The next The example is transaction to be performed to withdraw cash from the ATM. Set of operation. Consider the following example of transaction operation as follows. Example, ATM transaction steps. So we are seeing the series of steps what the transaction does. For the ATM, withdrawal of cash. Next, first is transaction starts. Insert your ATM card. Select language for your transaction. Select saving account option. Enter the amount you want to withdraw. Enter your secret PIN. Wait for some time for processing. Collect your cash. Transaction completed. Three operations are performed in transaction as follows. The first one is read access data, write change data. So read means R, write means W, and commit. Example, transaction of 50 rupees from account A to B. Initially, A is 50, B is 800. This data is brought to RAM from the hard disk. So, RAM of A, access from RAM. Next, deduct A 50 rupees. So, A is having how much? 500 minus 50. Then write operation is minus update the RAM is 450. Read of B is how much? RAM of B has 800. So B has to be added 50 rupees. 50 rupees. So what is the right option here? 850 commit. So these are the series of steps for the transaction. Note, the update value of A is equal to 450 rupees and account of B is 850. All instructions before commit come under partially committed state and are stored in RAM. RAM means random access memory. When the commit is read, the data is fully accepted and stored in hard disk. If the data is failed anywhere before commit, we have to go back and start from the beginning. We cannot continue from the same state. So this is called the rollback. Uses of transaction management. The DBMS is used to schedule the access of data concurrently, that is at the same time. It means that the user can access multiple data from the database without being interfered with each other. Transactions are used to manage concurrency. It is also used to satisfy acid property, as we have seen A for atomicity, C for consistency. So let's see what is atomicity. I for isolation and D for durability. As we have explained in the before slides. It is used to solve read-write conflict. It is used to implement recoverability, serializability, and cascading. Transaction management is also used for concurrency control protocols and locking the data. So the actual now we have seen what is transaction means. Its transaction states are can be implemented using SQL queries and server. In the below diagram, you can see its transaction states are, see, this is the active state, partially committed state, terminated state, aborted state, failed state. The active state, first it goes to the partially committed state, the read-write operation goes on. From there, it goes committed state with the stored operation. In case it is failed, it goes to the failed state and the rollback is there. So aborted states comes here. If the active state is also failed, it comes to the failed state. So failed state has two inputs, that is one is partially committed state and active state. And this goes to the rollback action and goes to the aborted state. If it is permanently stored, if it is done perfectly, it goes to committed state and the state is terminated finally. So these are the different transaction states in database management system. Now let's explain what each and every state does and what is this need. The active state is the first state of every transaction. In this state, the transaction is being executed. For example, insertion or deletion or updating a record is done here, but all the records are still not saved in the database. Partially committed. In the partially committed state, a transaction executes its final operation, but the data is still not saved in the database. In the total mark calculation example, the final display of the total mark steps is executed in the state. Next, the committed state. A transaction is said to be committed state if it executes all its operation successfully. In this state, all the effects are now permanently saved on the database state. Next, the failed state. In any of the checks made by the database recovery system fails, then the transaction is said to be in the final state, failed state. In the example, the total mark calculation, if the data is not able to fire the query to fetch the marks, then the transaction will fail to execute. Next, aborted state. If any of the here is fetch the information actually. information. So, next, the aborted state. If any of the checks fail and the transaction has reached a failed state, then the database recovery state will make sure that the database is in its previous consistent state. If not, then it will abort or roll back the transaction to bring the database into the consistent state. If the transaction fails in the middle of the transaction, then before executing the transaction, all the executed transactions are rolled back to its consistent state. After aborting the transaction, the database recovery model will select one of the two operations. What is that operations? Restart the transactions, kill the transaction. Next, next topic is implementation of atomicity and durability in database. Next, before that, let us see what is requirement. Requirements, write ahead feature, move update records to log on MOS store before database is updated necessarily to preserve atomicity. So new values written by the transaction must be on the mass store when it commits record to return to log. Move new values to mass store before commit record to preserve durability. So we have to see that. So write ahead features to preserve atomicity and return by the transaction to be mass stored when it commits the record to return to log to preserve the durability. So the importance of atomicity in database. Atomicity preserves the completeness of the business process. Consistency refers to the state of the data both before and after the transaction is executed. A transaction maintains the consistency of the state of the data. In other words, after running the transaction, all data in the database is correct. Many databases implement durability by writing transactions into the transaction log that can be reprocessed to recreate the system state right before any later failure. A transaction is deemed committed only after it is entered in the log. Atomicity and durability of the transaction is implemented by the recovery management. The recovery manager is responsible for ensuring atomicity and durability. Atomicity is guaranteed by undoing the actions of the transaction that did not commit, that is aborted. Durability is guaranteed by making sure that all actions of committed transactions survive with crashes and overcome the crashes and failures with no memory loss. Atomicity and durability mean in transaction is In computer science, the ACID, that is atomicity, consistency, isolation, durability, is a set of properties of database transactions intended to guarantee data validity despite of errors, power failures, mismatch, and other mishaps. Technique to use implementing atomicity and durability. The that implementer of atomicity and durability using shadow copies. So this is the technique used, is one of the technique, the latest technique used in the implementing atomicity and durability. Okay, the next one is scheduling. So let's see what this scheduling means. Schedule a series of operations of one transaction to another transaction is known as schedule. It is used to preserve the order of operations in each of the individual transactions. Schedule is divided into three parts, that is serial schedule, non-serial schedule, serializable schedule. So let's see, our topic is serializability. Serial schedule. Uh, but before going to seriability, we have to know what is the schedule parts and what is the role of seriability with the pre-concern of serial schedule and non-serial schedule. So let's have a brief knowledge of that. The serial schedule is a type of schedule where one transaction is executed completely before starting another transaction. In the serial schedule, when the first transaction completes its cycle, then the next transaction is executed. For example, suppose there are two transactions T1 and T2 which have some operations. If it has no interleaving of operations, then there are the following two possible outcomes. Execute all the operations of T1, which has followed by all the operations of T2. In the given schedule shows the serial schedule. Next, T1 follows the T2. In the schedule B follows the serial schedule when T2 follows the T1. Non-serial schedule. Here, actually, here what happening is T1 is followed by T2 and T2 is followed by T1. So there is some like a circle. Now next comes to, so that is called serial. So one after the other. Non-serial schedule is interleaving of operation is allowed. There is no, they then they will be non-serial schedule. It contains many possible orders in which The system can execute the individual operations of the transactions. Schedule C and D are the non-serial schedules as it is having interleaving operations. Serializable schedule. This is our main topic. So it is also called serializability. The serializability of the schedules is used to find non-serial schedules that allow the transaction to execute concurrently without interfering with one another. It identifies which schedules are correct when execution of the transactions are interleaving of their operation. The non-serial schedule will be a serializable if and only if it has this following. Suppose C here T1, read A is A minus N, write A, read B, B is B plus N, write B. The transaction T2, read A is A plus M, write A. This is schedule A and this is schedule B. As we have discussed here in the previous diagrams.